Okay, so let's clear up current, potential difference, and resistance. Okay, so first of all, I have to remember that a circuit is like a road, and you can only travel one direction on the road. Here's the start and the end, so that'd be our cell. And you also have to remember that the entire road is jam-packed full of electrons. So when one starts moving, they all start moving. The speed of the one coming out of the cell dictates the speed of all the other electrons. There's no passing of other electrons. Current is a measure of really how fast are the electrons moving through the circuit. So here's my little electron guy, and here he is going pretty fast. It's measured in amps, number of electrons moving past a point per second. So any point, if I stood there and I watched and I counted electrons, that would be the number of amps. 1 amp is a surprisingly huge number of electrons. 6.2 with 18 zeros behind it, moving past a point in a second. That is a lot of electrons. Potential difference, we also call it voltage, is the amount of energy that the electron gives to the load. Okay, or the difference between how much it had before it went in the load and how much it has after. Here, lots of energy, less energy. What that potential difference is and what your voltmeter does is measures how much energy it gave to the light bulb. Okay, cells here give energy back to the electrons. So they would go in with less energy and come out with more energy. Resistance then is caused by things like loads, and they slow the electrons down as they pass through the load. So basically, they have to give it energy. They have to give the light bulb energy, so they slow down while they do that.